Okay, this is problem 4.16 from the Hagen textbook, and it illustrates the process that I'm hoping that you can go through for the first exam. All right, so in this problem, this might be longer than what I would expect you to do on an exam in terms of how to solve the problem. We'll talk about that as we go through, but the setup on this is pretty straightforward, and I'm hoping that you'd be able to get to this pretty quickly on an exam. All right, so we're wondering what force needs to be exerted by the worker on the cable. So this is, I guess this hand here is the worker pulling on this cable that deflects the connection point and the box that's being suspended by the crane. Okay, so we have a cable deflected, we have something pulling, we have a weight hanging from point A. All right, so let's draw a free body diagram, and you have to ask yourself the question, what do we want the free body diagram of? Okay, and I think it makes some intuitive sense if you think about it, and as you see some of these problems. It makes intuitive sense to do this at point A, okay? Because that's where all the action is. All right, we have the weight hanging down, okay, so we can draw a free body diagram, call that W. Okay, we have the cable that's deflected a little bit, so I'm going to draw a straight line here, and then the force goes at 5 degrees. Okay, so we put in this angle here is 5 degrees. All right, and then we also know that there's a horizontal line and another force that's being exerted at 10 degrees. Okay, all right, so there's a free body diagram. We should label some of the forces. So maybe I would call this TAC because it connects it at point A and goes up to C. And then I would call this TAB because it connects at A and goes to B. All right. Do you see that? Hopefully you see that. Ask yourself that question. Do I understand this free body diagram? There's no other forces acting on point A. All right. And so I've worked a lot of these problems, and so I start to mentally look ahead. All right. And I'm thinking, I know that I'm going to use certain equations, some certain governing equations. First of all, whenever I see a mass hanging, I know that the weight is the mass times gravity. So that's one of the governing equations. That's an easy one. But I'm also going to look at sum of forces in the x direction equals 0. All right, and I see that, and I see two forces that have x components. The TAC and the TAB both have x components. The weight is all in the y direction, but I'm thinking that's good. That gives me one equation, okay? But I don't know two things, all right? So one equation, two unknowns. It turns out there's going to be a theme showing up in this course. If we have two unknowns, we need two equations, okay? So I'm thinking ahead. I can do sum of forces in the y direction equal to 0. And that would give me the second equation. So I'm feeling pretty good about moving forward. I know I can write sum of forces in the x direction, sum of forces in the y direction, get two equations, and I would have two unknowns. So I'm thinking here, how did I know what was known and what was unknown? Well, I don't know this force that wasn't given. I don't know this force that wasn't given. I do know, I'll put this in green, I do know the weight, because if I had the mass, it's just mass times gravity. So two equations, two unknowns. All right, so let's get started with that. And this is kind of the layout I'd like to see on your exam. You do the free body diagram. I'm not going to ask you for a free body diagram. I expect you to do that, all right? If you don't do that, you potentially lose points. In fact, I can say you'll lose points if you don't have a free body diagram and a free body diagram is appropriate. Okay, on the other hand, if you don't know how to start a problem, get started with a free body diagram, and that usually helps you get unstuck. Okay? All right, so moving forward, sum of forces in the x direction. Now we're going to need to use a little bit of trig. Okay, and so I take a look at this and I'm thinking I'm going to decompose TAC into an X direction. Okay, so I draw a little diagram there. And this angle is a little odd because the reference point is pointing straight up. Okay, normally when we decompose something into the X direction, we end up with cosines, but this force is opposite of the angle, and so sine is appropriate here, okay, because sine is opposite over hypotenuse, okay? So I'm looking at that, and I need to decide on a coordinate system and a direction, and so normally what I do is to the right is positive x, and up is positive y. All right, so using that as a decision point, we can come up with this first equation. All right, I would have for the sum of forces in the x direction minus TAC, and it would be sine of 5 degrees. All right, so that takes care of the horizontal component of this force. What is the horizontal component of the weight force? Well, it's 0 because it's only moving in the vertical direction. And then finally, I need to take care of the horizontal component of TAB. All right, and so this is more the usual format because this mark it in red on this triangle, this force triangle. The angle is attached to the adjacent side, and so this would be TAB cosine of 10 degrees. All right, so we're feeling pretty good. All right, we've gotten the two forces in the X direction. And one of the things I see when you're first starting to work these problems is the tendency to stop right here. Okay, but remember, this is an equation. These sum of forces equal 0, so you have to have an equal sign for an equation. It gets confusing later on when you try to solve things and there's not an equation there. Okay, so don't forget the equal 0 part. Okay, next. The next step, sum of forces in the y direction equals 0. Y is up. Okay? All right, so I break this down and let's look at TAC. In the y direction, okay, I'll make this in green. The y direction of this force is right here. That's the adjacent side to that 5-degree angle. All right, so I would need cosine. Okay, so this would be plus, right, because it's moving up, TAC cosine 5 degrees. All right, so that gives me the first vertical component of TAC. All right, so the second component for TAB would be, all right, again, let's go green here. It's going to be this component going down, right? It's going down because TAB is angled down by 10 degrees. Okay, so instead of saying a plus, this would be minus, because it works down, minus TAB, all right? And then that's the opposite, right? Opposite of that angle, 10 degrees. So this would be sine of 10 degrees. All right, and then there's one more force, right? Look at all the forces. The weight force moves down, so minus W equals 0. Okay, so I'm looking at this. Here's my second equation. Let's highlight the things that are unknown. We don't know TAC, we don't know TAB, but we know everything else. All right, we know weight, okay, because weight is 500 kilograms times 9.81, and this would be in newtons. Okay, so at this point on an exam, I might ask you to stop. Write the two equations, all right? And we're separating out writing of equations and solving of equations, all right? So those are two different processes. We just wrote the equations for this system. The next step would be to solve them, okay? And I'm not going to make that the focus of this video. We're going to talk about, maybe I've already shown you a video about solving equations rather than simply just writing the equations. All right, so what I have next is the MATLAB setup for checking your answers. All right, you should be able to solve equations by hand, but a lot of times if you're trying to practice a lot of problems, you want to practice the thing that's hard for you. In general, I think solving the equations is going to be really pretty straightforward. It's just a matter of turning the crank and getting through it. All right, so here is MATLAB code, and I want you to be able to write this on your own. It's got some weird syntax, but we'll talk about this with several videos so that you can get this down. The first thing you have to do is define the symbolic variables. Okay, MATLAB's expecting these to be symbolic. You put in some of the things you know, all right, and then you write these equations, all right? So you see here I have equation 1 and equation 2. They're exactly as we had written. The catch is, things I want to highlight here, are I use the D for the sine function. That just tells me my argument is going to be in degrees instead of in radians. Okay, so everywhere I used a trig function, I had the D showing me that I wanted that to be in degrees. All right. Then it's just, I just wrote out the equations. And the other weird thing that I want to point out is the double equal sign. Okay. That tells me this is a logical mathematical equation. If I just have a single equal sign like I do here, I'm assigning a variable to a certain value. And that's a slightly different process. So when you write equations, double equal sign. Okay, when you're assigning variables, single equal sign. Okay, all right. So from there, I just use the command solve. All right, so I solved the two equations and I put down next the two unknowns. All right, and that gives me the answer in something called a structure. And you can pull things out of the structure with an eval command. Okay, so from there, I just want to know the answers, TAC and TAB, and I say eval s.tac, that pulls out the answer for the tension in the cable AC. And the same thing with eval s.tab. All right, so hopefully this helps you. Watch this video, try to absorb this, and then pause it and try to rework the problem on your own, okay? Write all the equations without looking at the video. It's easy to watch these videos and think you know what you're doing, but then when you try to do it yourself, you get stuck. So it's very important to do that. Okay, that's the solution to 4.16.